Okay, so we've spent some time doing a few stats already, but we really want to start spending some time really crunching the numbers. And there are going to be stats here, your single variable stats that you're going to be familiar with, although we will be doing more elaborate versions of those than you would have done in grade school. But they would have been familiar from grade school. At the 3Ms, I suppose, mean, median, and mode. These are all what are called measures of central tendency. So in other words, they kind of tell you where the overall center of the data lies, the center of mass, if you will, the center of tendency. And then that's the idea in the name. Okay, then we're going to start with the simplest of all of them, although it has the most versions and it can be the most complex to calculate. We'll start with the mean, also known as the average. Okay, and then we'll look at the median after that, and then we'll look at the mode. Finally, the mode is fairly straightforward. The mode is the most frequent value. So if you're going to look at a frequency diagram and go ahead and do that, then your mode would be the value that appears the most, or if it's a group, the midpoint of the group or interval that appears the most or has the highest frequency. For the median, it's a middle value. If the values are lined up from smallest to biggest, it's the one that's literally in the middle. And then the mean is all the values added up, quantified, and then divided by the number of individual data points that are out there, and then of course determined as sort of an average. And I think we're kind of familiar with the average because of course that's what we usually look at when we look at marks, although the marks that we have are weighted averages, but that's neither here nor there. Most people are used to seeing a mean. That's usually what you get as a final mark, and so it's something that you're somewhat familiar with. Okay, we're also going to introduce some symbology, that is symbols that we use to represent either mathematical operations or some quantities that we see in all of our formulas. And then we're also going to look at some calculations that take place. So there'll be a fair bit of material in here, even though the concepts are fairly straightforward. And then we'll look at grouped. We've already seen how to group data and find frequencies and midpoints for intervals. Now, of course, we're going to take that data and look for grouped means for those as well. And of course, some information is lost when you group values. And with the grouped mean, we also calculate it a little bit differently than we would what we call a raw mean. Okay, so we'll start with right here, the raw mean. Okay, the raw mean is the middle measure of central tendency for the middlemost value. It's very effective to use in all data sets, but it's actually quite useful to use in data sets where we don't tend to have really large, extreme, ridiculous values. Okay, so you look here, the values that we have here. These are examples of rolls that I had of rolling 2 dice and adding them up, and the sum of 2 dice. So kind of like you're playing a board game like Monopoly. But notice that the values here are not too extreme. We've got a 2 as the lowest, we've got a 12 as the highest, but we don't have like a 144. Right? Or like, I don't know, a negative 20 or something here, where we have values that are very extreme. If we have extreme values, we tend towards something called the median, which is insulated to the actual values, whereas this one takes the values and it's involved in a calculation. The median, it just takes the position in a sequence, so it's a little bit more insulated for extreme values. So in this data set, I definitely would use the mean rather than the median, or at least both would be valid. Okay, and I'll show you an example where the median would be better to use than the mean a little bit later on. Anyway, to the raw mean. Now, a little bit of terminology to start with. Okay, first of all, we do have different formulae and different letters that we use for a population and for a sample. Okay, so a population or a sample, okay, because a population is the entire grouping. It's got a little bit more statistical power to it and reliability, whereas a sample, of course, depending on the size and how much of the fraction of the population, how it was taken, we have a little bit less confidence with it. Now, the nice thing is these formulas are exactly the same, but the letters that we use are a little bit different. So you're going to have to get used to symbols that go along with this. Okay, so first things first, for a population, the formula is straightforward, simple. What we do is we take all the values and we add them all up. Okay, and then we divide by the number of values that are there. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. And then we take the sum of all these values and we add them all up. Okay, now, the way that we write that in a formula, first of all, is we take x sub 1. Now, each one of these, each individual data point has got an overall abbreviation for x sub I. I means any particular value in the sequence. It usually goes from 1 all the way through to the very last data value, but there's no definite order to it. X sub I just means any individual data value. And I like the idea of the individual data value, not that the I stands for that, but it's the individual data value and individual random variable X value. Okay, so our single variable stat, let's say we were looking at die rolls, X sub I would be any individual die roll. So 12 could be an X sub I, or 6 could be an X sub I. Now if we want to be specific to them, if you notice here, it goes X sub 1, X sub 2, X sub 3, X sub 4, all the way to X sub n. So that would be X sub 1, X sub 2, X sub 3, X sub 4, X sub 5, X sub 6, X sub 7, X sub 8, X sub 9, and X sub 10, or X sub n, the final value. Okay, in this particular situation, we take all the values from the first to the last and we add them all up, and you see plus signs or addition signs in between those. For those of you guys who took grade 11 U math, you would have done sequences in series, so you'd be a bit familiar with these. We would call that probably T1, T2, T3, all the way to Tn, the very last term, or the nth term. Okay, you'll also notice a large N. A large N is going to be the population size, which is also corresponding to the number of data points that we have. In this case, it's 10. For the overall statistic, we use the abbreviation of the Greek letter mu. So it's a U with a tail kind of in the front of it. Okay, that's the Greek letter mu. So whether it's mu or for a population or for a sample, we use X bar. X bar and mu are kind of potato, the same thing. Except mu is for the whole population, and X bar is for a piece of the population, a sample of the population. You'll notice the formulas are structured exactly the same thing. I take all of the X values from the first to the last, all of the X values from the first to the last, and I add them all up. I also divide them by an N, but you'll notice that one is a lowercase n, which is a sample number, or the number of individuals in the sample, whereas this is the population size, or the number of individuals in the population. N stands for number. Very simple, very straightforward. So in this case also we would have 10. So whether this is from a sample, if this was a board game, I'd probably be playing a lot more rolls than this, so it would be a sample. Or if, I don't know, I just took a bunch of dice and I rolled them 10 times, and that was my whole population, that was it, then that's it. Or a very, very short board game. Okay, so that being the case, this could be a population or it could be a sample, depending on how it's viewed. We have to know some more information to actually define it as one or the other. Nice thing about it is the take-home message is either mu or X bar for a population or for a sample, is all of the values added up divided by 10, which is 72 divided by 10, or 7.2. That is what we would call my raw mean. Okay, 7.2. Very simple, very straightforward. Okay, the mean that you're used to even when you were in grade school and that you calculated. Now, of course, we have to elaborate and use more complicated versions. And we do have one version that's very commonly used for your final marks, as well as for marks and tests and quizzes if you have different categories. Okay, and those are called weighted means. That means that each category has a different value or power, statistical power associated to your mean. So it doesn't mean that every data value is the same. For our course, we have weightings. For knowledge and for application, we have weight factors of 30%. So 30%, 30% for knowledge and application. But for thinking and communication, it's only worth 20% each. That means that if you get an 80 in knowledge and you get an 80 in, say, communication, the 80 in knowledge is actually worth more towards your average than the 80 in communication. Okay, so there's categories that are worth different amounts. Kind of like when you go to I don't know, a restaurant or something like that. Maybe one of the most important things that you weigh is how it looks in the menu. Another thing may weigh on, is it chicken because you like chicken, or does it come with fries? And that's a higher weight factor for you. So any decision making that you make, not everything is treated equally. Okay, and so as a result, that's a weighted average that you're creating. So this is a natural thing to do, but it does involve a little bit more complicated scenario. First of all, we still use mu and we still use X bar, but we put a little sub W on it for weighted mean. Okay, so population weighted mean and sample weighted mean. Nothing too crazy. Now, what we also do is we have two values that we actually have to multiply together. Wi, which stands for the weighting, or what some people would call a weight factor. And then x sub I is the actual score. Okay, the actual value that you measurement, the actual measurement. And what you'll notice is what we do is we take the value and we multiply it by its weighting. In essence, what we're doing is we're counting it more or less times than we would, whereas in the raw mean, we don't do that at all. We count each value once. Well, in a weighted mean, we count some values more times than the other ones. And so I'll show you this example. I'll also show you a better format to use it, which is a tabular fashion, which is a bit more appropriate. So here we have a multiplication that we have to do first, and then we do the addition. So remember your BEDMAS, you do multiplication before you do addition. This is a situation where you have to do multiplication before you do division. Okay, so you take the individual value and its particular weight, and you multiply them together. You do the same thing for another value, the second value, x sub 2, and its weighting, and you multiply those two guys together. So you do that first, and then you add them. And you keep on going down the line until you run out of values and weightings to go along with them. So I'm going to show you how to do this, because it's a little easier to show you than to look at the formula and say, oh, that's how it works. Now, what's also important is we don't put n down here. We put all of our weightings. So we actually add up all of our weightings in the bottom. So we're not dividing by the number of data points that we have. We're dividing by the number of times that we counted the data points. That's what the weight factor is. Okay? So it's a little bit more strange of a calculation. So again, we need to do it by example. I'll come back to this formula. Okay? But this means add them up. It's called a summation. This is the operation that we need to do. We do this first, and then we do adding them up second. Okay, and so this is WIXI, which is the weight of any value, times the actual value. Okay, and you notice in the bottom, it's the summation of WI, which means it's just the weight plus the weight plus the weight plus the weight all added up. We don't have to simplify that first because it's just the weightings, so this is what we would do first. Okay, so let's look at an example of that. And I'm going to show you how to do it practically as we move along. So this is an example, okay? A unit test with 4 categories. All right, so you have a unit test. On the knowledge section, you got an 82. The thinking, you got a 78. The application, you got an 86. And the communication, you got a 79. Now, what's important to understand is that these marks are not created equally. Okay? Now, when we do this, you can do this sort of in a straight line fashion, but I think 1,000% of the time, it's better to do it in what's called a tabular fashion. So I'm going to take these values and I'm going to put them into a table. So this is going to be x sub I. Okay, now I'm going to, of course, show you a table, which is over here. Now this is already calculated for us, so you have to follow along with me. Okay, so this is the table that we know so far. This is the mark we got in knowledge, the mark we got in thinking, the mark we got in application, the mark we got in communication. Okay? If we wanted a raw mean, we'd add them all up and divide by 4. But that raw mean, these categories are worth different amounts. So we can't do that. What we need to do is we need to apply a weighting. So there's my WI, there's my XI. So I take the mark, my measurement, and I multiply it by my weight factor, which is, it's worth 30%, so I multiply it by 30. Okay, so 82 times 30. Okay, now I don't put a multiplication symbol in here, but they're side by side, 82 times 30. So here I have WIXI, which is exactly what I want. If you remember the formula, mu G or X bar G is equal to adding them all up of WI times XI. Okay, which is exactly what this WIXI. So what I'm going to do is do all these multiplications and then I'm going to add them all up. You'll actually see a sum category in there too. Okay, so anyway, so that's what we do. We take the 82 and we multiply it by the 30, its weight factor, and we get 2,460. Okay, we write it down. We take the thinking and we multiply it by its weight factor. See how it's worth 20% rather than 30%? So I'm counting this 30 times, I'm counting this 20 times. That's what creates the weighting. 20 times 7, fruit flies. 20 times 78, you multiply that and you get 1560. You take the application mark and you multiply it by 30 and you get 2580. And then you take the communication and you multiply that by 20 and you get 1580. And that fruit fly. And that, of course, creates all of these numbers. Now, of course, that's not what your average is on the test. You know it's not going to be in in the hundreds and thousands. It's just ridiculous. Okay, so you know that we have to finish the calculation. All right, so now what I do is this. Okay, I do summations. So I do my operations up here, and then I do my summations down here. So operations in the table, and then summations in the sum categories that exist there. Remember, the formula is the sum of wi times xi. So I take wi times xi, and I add them all up. That becomes the top of the mean. The bottom of the mean is the sum of wi. Well, this is wi, so I add them all up. And you're going to see that it's going to, of course, come up to 100 because 30, 30, 20, 20 adds up to 100. We always create those for our categories, and that's going to go in the bottom of the calculation. Okay, so it's kind of like a grocery list. This is my top, and then I have to add them up to create my numerator. To create my denominator, this is my bottom, and then I have to add them up. That's what the summation is. And so you do the work all outside of the formula, and then what you do is you plug them in. So what I've done here is I've kind of plugged them in or substitute them, but I may also substitute them down here. So here's the formula, mu weighted mean, or mu w sub w, or x bar sub w, is equal to the sum of wi xi, this thing, wi xi, divided by the sum of wi. And I go 8180 divided by 100, and I get 81.8. This is the weighted mean. That's what your overall average for the test would be. So whenever your teacher gave you your test back and you added up your 4 marks and you divided them by 4, you weren't getting an accurate average. Your teachers wanted you to go ahead and multiply it by these different weight factors, which is why the mark summaries were more important for you to get in mark book and stuff like that, when your teachers can kind of tell you how it all sort of crunched out. Okay? So that's a weighted mean. Now, of course, a grouped mean. We have grouped data that we've done for our frequencies. We better have a grouped mean to go along with it. If you remember, in our grouped values for our frequencies, we lost information. If we put things in a category of 10%, whether something was a 61 or whether something was a 69, it didn't make a difference. It still went into that group. Okay, and then the value that we associated with that group, which we didn't really talk about when we were doing grouping data, actually ends up being the midpoint. That means 69 is approximated by the midpoint of 60 to 69. 61 is also approximated by the midpoint of 60 to 69. It's the same idea here. So I'm actually going to use the same data that we had from our frequency diagram that we did before. So for a grouped mean, first let's look at the symbology that we use here. Again, the mu sub g, or the x bar sub g. Kind of familiar, hopefully now. Mu and x bar are means. One's for a population, one's for a sample. The sub g means g for grouped. It's not rocket science. It's pretty straightforward. What we do, though, is kind of the same thing as a weighted mean, but what we do is we take not x sub I, we take m sub I. Now, what is m sub I? That's my midpoint. Because if you have a group from 60 to 69, what number do you use? Do you use 60? Do you use 69? Do you use 61? Do you use 67? No. You use the rough average of that grouping, which is the midpoint of that group. So that becomes an important value. That's kind of like your x sub I. It's your m sub I for your group, only for grouped data. And you can see here that we have a grouped interval. From 39.5 to 49.5, I use 44.5. That's the midpoint. If you want to find out what that value is, you take that guy, you add them up, you divide by 2, and you get 44.5. It's not crazy. Okay? Same thing for every other group. Okay, and you get all of these midpoints. Okay? So I take my midpoint and I multiply it by my frequency. Remember, I do that multiplication first. So I take my frequency, which is 1, and I multiply it by my midpoint. Fi, Mi, or F1 times M1. I take the frequency for the second one, and I multiply it by the second midpoint. F2, M2. And then we take the frequency of the third one, and I multiply it by the third midpoint. I don't have that listed here, but these are all the guts, and then finally this would be the last one. Okay? Again, you'll see this in a tabular fashion. And again, you see this summation, because once I figure out what all these individual numbers are, then I add them up afterwards. So this is 1, this is 2. You multiply them all, then you add them up. That's again why a column system works for this. Trust me, if you do this in columns, you're going to love it. If you don't do it in columns, it's going to get kind of crazy. You can still manage, but you got to be really good with your work. Okay, and really, really fastidious and organized and not drop decimals and remember who to add and all that sort of stuff. If you use Microsoft Excel, this is kind of the same thing as a tabular fashion, but you can do different formulas and stuff. Now, what's the overall formula for mu sub g or x sub g? I add up the frequency times the midpoint and I divide by the frequency. Add it up. Okay? And it makes sense because my frequency kind of is my population size or my sample size, so it does make a bit more sense than the weightings, but it's kind of structured just like a weighted formula, except it's weighted by the midpoint is the value and it's weighted by the frequency because the frequency happens more often, it's repetitive. Okay, so that's the idea. This is for grouped data. All right, so again, let's go through how that all happens. Again, if you look at the formula, first thing I have to do is this, my frequency times my midpoint. So I take my interval, I write my midpoint, and I multiply it by my frequency. 44.5 times 1, 44.5. Nice. Then I take 49.5 and 59.5, midpoint 54.5, multiply that by its frequency, 4, and I get 218. Midpoint times frequency, 451. Midpoint times frequency, 819. Midpoint times frequency, 507. Midpoint times frequency, 283. Okay, I get all of those values, so I do that first. That's what this column is for. It's FIMI. And then what do I need to do? Then I need to add it up. That's number 2. So what do? Old school column addition, carry the 1 and all that sort of stuff. And you get 2324 when you add that up. That's my numerator. For my denominator, I have to take my frequency. I don't have to do any work with that because it's individual frequencies, and I have to add them all up. So that's really the only thing that you have to do. So you take your frequency column and you add them all up. And this is the sum of the frequency, Remember, this thing is equal to this little ziggy-zaggy Greek letter sigma. Okay? So now I've got my denominator. So I take my numerator, divide by my denominator, beep, boop, boop, done. There it is. 72.625 or 72.6 probably, or whatever you're going to round it to. I don't know. Okay, so that's your grouped mean. Fairly straightforward, fairly simple, not crazy. It's something you want to practice and get used to because the formulas are going to get a little crazier for our measures of spread that we're going to have for our next lesson. But still, not too crazy, not too bad. So that's means. Okay, we've got a raw mean, add them up, divide by the total. We've got a weighted mean, which means multiply each value by a weight factor and then divide by the weights. And then we've got a grouped mean. Multiply the midpoint times the frequency, add them all up, and divide by the frequency. Okay, nothing too crazy. And remember, you're going to have access to all of these formulas when you write a test or when you do an assignment. Okay, they're all in the very, very back page of the textbook. That's in your reference list. So keep that in mind as well. Okay, all right, so that's that. That's means. Now let's look at the median, which is thankfully a lot easier. And there's a grouped median and there's a median, but they're pretty much the same thing. Okay, it's really the middle value from the lowest to the highest. Okay, so the median again is the middle value of the data set. Okay, when it's listed from least to greatest. Be careful, sometimes they list it from greatest to least, and if you're going to pick values, although the median is still going to be in the middle, we're going to pick other values later on, so keep that in mind, make sure you have it in the right order. Now, for this data set, 1 all the way through to 16, there's really no extreme data values, so the use of a median is not any better than a mean in this situation. So in this situation, a mean really is equal to a median. It's not very repetitive, so a mode is not useful. Okay, although we do have some repetition with the 2 10s. Okay, or maybe you want to do both stats and compare them to each other. This one is a bit different. What you're going to notice is a huge value of 1,006 and 2 very low values at negative 451 and negative 222. Those would make the mean biased. The 106 is going to pull values up and the negatives are going to pull it down, and it's going to make it inaccurate. Okay, so this would be better for a median type scenario. And the reason why is this or this doesn't really affect the value of the median. Yes, it does when you add a value and it shifts the median over one, but you still find it in the center of the heart of your data. And so the median insulates you from very, very high values and very, very low values because this number is not added into a value. It's just treated as first spot, second, third, fourth, fifth in order. And so as a result, it's a more effective one. Okay? So what I'm going to do is show you how to do a median in the most complicated scenario, and it's not complicated. It's very easy to do. What you do is you count the number of data points you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data values. If you have 16 data values, that means that if you divide it by 2, 16 divided by 2, you get 8. That means that there's 8 below and 8 above your median. Okay, that would divide the values in half. The halfway point, another way you can do it is you can start from this end and count in, and start from that end and count in, and see when you meet. 1, 2, 3. It's a little bit awkward to do if you're not I'm right-handed rather than left-handed, but if you're ambidextrous, it's okay. But you can knock them off one at a time. And as you do knock them off, it's my cat snoring in the background. Hopefully you're not hearing that. You knock them off, you're going to start finding out, hey, wait a minute, my median's right in between these two values here. And it's true. It's right in between two values. It's between the 8th and the 9th value. So again, with 15 data points, the median would lie exactly on the 8th position. So if I had these data points, my median would lie 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It would lie exactly on the 8th. So if you have an odd number for n, your median is on a value. But here we have an n is 16, which is even. So your median is going to be between. Is between two values. And you'll see yourself, I can't even read that. It's okay, don't worry. Like I said, if you look at your good copy for your notes, I do explain it a little bit more. Okay, I'll also show you a little formula that you can use to figure it out. Okay, and I'll show you that in a second. Okay? All right, so for most people, they're like, okay, even number, it's between two values. Which is it between? Well, it's 8 on this side and 8 on this side. But if you had, like, say, 150 data points, it's difficult for you to sort of visualize where that would be and count to that value. So there's a formula that you can use. Okay, you can use the formula n plus 1. N plus 1. And then you multiply it by the halfway point. That's what the median is. Okay, so you take your 16 plus 1, that's 17, 1/2. That's 1/2 times 17 is 8.5. And that tells you, okay, that it's going to be on the 8.5th data value. If it's going to be in the 8.5th data value, it's going to be between the 8th and the 9th data value. Okay, and anything between the 8 and the 9 is on the 8th to the 9th data value. So it's not rocket science. That formula is quite useful. A lot of people like to use that for the median. And this is what makes it a median, because we do vary that when we look for something called an interquartile range later on. Okay, so that helps people figure out what the median is. Now, because it's between two values, what do you do with those two values to figure it out? Well, to figure out what those two values are, you take your 8 plus your 9 and divide by 2, and you make a little mini average. So your median would actually be 8.5. Ironically, it's also in the 8.5th position, but your median would be 8.5. Okay? If we were to do a median for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. For this one, there's 15 values. You can, again, use the formula. You can go 15 plus 1 15 plus 1 times 1/2. 1/2 times 16, which is equal to 8. That means it's going to be on the 8th exactly. And that's exactly what it is, the 8th. 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. The median's exactly on the 8th value. Okay? Now, it just so happens as a coincidence that the 8th value is 8. Okay? Or the 8.5th value is actually 8.5. All right? The last thing that we look at is the mode. The mode is useful as a measure of central tendency if you have a repetitive data set. I don't know if I even remember, but I mentioned before, you know, the number of coffees that people order when they go into Tim's. There's probably like a lot of people who order 1 and a lot of people who order 2. Not a lot of people who order 10, not a lot of people who order none. Okay, so 1 and 2 would be very, 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 very common in your data set. That would be something where you would want to use a mode. And you don't even have to have one mode. You can actually have multiple modes. So if you look at this data set below, you're going to see that the 7s repeat a great deal. So rather than using the median, which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 values, you go 17 plus 1. 1 over 2, that's going to be 1/2 of 18, which is going to be 9. So the median would be the 9th value, 1, 2, 3, 4, 5, 6, 7, 8, 9. The median would be at 7, but the mode would also be 7. In this case, very repetitive. Okay? There's no other value that occurs very often. You do see a little mode at 10, but it's not as large or as common a situation. If we modify the data set a little bit and I just adjust the 7s and have a few less 7s, we can actually have 2 modes. And in this case, you can be bimodal, in which case you have mode 1 and mode 2. And it's okay to have a couple of modes to understand where the measure center tendency maybe lie in between those 2 values or whatever, depending on the situation. Okay, and you can also see that in a frequency distribution. So you can see this in a frequency distribution or frequency graph, or relative frequency distribution or relative frequency graph. But you can also see it when you crunch the numbers on the data set. So go ahead and give those a try. You're going to have a challenge probably with the grouped median, but I want you to try to work your way through it, and then I will take up that work with you. That's definitely going to be a one you're going to want me to take up on these measures of center tendency. Okay, so hopefully that makes sense to you. There's a few things after that. They do want to bring up the idea of outliers in this particular section in your textbook. Okay, outliers are extreme data points that are found very, very far outside of our data set or are very unusual. So we call them extreme data points or outliers. Some people think that outliers should be discounted. I don't think they should be discounted as long as they can be proven to have been measured correctly and they aren't anomalous or mistakes. And if they seem reasonable in that sense, then they should be included. But one thing that you can do is you can try the stats with and without that data set and go from there. We'll actually define what an outlier is when we talk about measures of spread in our next section quantitatively, and actually find what an outlier is in our very last section that we do. Okay, when we're looking at a normal distribution. Okay, so it's going to be a little, I mean, you got a fair bit of homework there to do, so go ahead and get to work on that.